All right, here's going to be option number 2 when we're going to be multiplying binomials. So we can, we can put it into a table, okay? What that means is we've got our headers, we've got our row headers, and what we're going to do is we're going to look at each term. So here's a term 2x. Here's my term 2x. I'm putting it into the table. That's my header. Think of it like a multiplication table. On one side, you have 0, 1, 2, 3, 4, 5, 6, 7, however far you're going to go. At the top, you also start at that same 0 and start going over to the right. 1, 2, 3, 4, 5, 6, 7, however far you're going to go. And in between is their actual products. Well, that's exactly what we're doing here. So we've got our -3, and there's our -3. All we're doing is splitting up our terms and creating a multiplication table like you've done before. Well, now I see that 2x times x is 2x squared. Because I'm going to multiply the coefficients, and then I'm going to, since the variables are the same, I'm going to raise it to the power, or add their powers. All right, now I have x times -3. That's just -3x. All right, at this point, I've got 5 times 10x, 5 times 2x, which gives us 10x. And now we have 5 times -3, which is -15. Now, I could rewrite this. Let me go ahead and do that real quick. I could come out here and write this just as 2x squared minus 3x plus 10x minus 15. Now, combine all my like terms. There's no other x squared, so that stays the same. I have a -3x and a positive 10x. That's going to make a positive 7x. And then there's no other constant term, so that just stays by itself, and I'd be done. The other thing I could have recognized is I could have combined these two when I brought them out in the first place. So what I mean by that is I could have recognized this is a 10x and that's a -3x. And as I brought them out, I could have gone ahead and in my head or on paper shown that it's just that positive 7x. And this is how we use a table to multiply binomials.